Hi, this is my project for Big Data Analytics course, CSCI E63. It's titled Exploring and Predicting Energy Efficiency Using Big Data. By exploring, I am referring to the factors that affect energy efficiency in buildings, both residential and commercial. And by predicting, I am referring to being able to predict energy efficiency metrics using various information available for these residential and commercial buildings. So starting off with an introduction, energy requirements, meeting energy requirements globally is a major challenge for us in the present day due to the increasing population and considerations of the environment due to most of the energy being fulfilled by fossil fuels. So we are unable to meet global energy requirements at present, and the US is the world's largest consumer of energy. Based on 2008 statistics, residential and commercial buildings in the US consume 41% of the total energy used in the country. So buildings can be regarded as a major player in the energy equation for the US. And energy efficiency is of paramount importance in order to be able to sustain energy requirements for the country in the future. Therefore, we need to study this topic in greater depth and improve our understanding in order to have a better control over our energy demands and being able to meet them in the future. It would be particularly useful to have models that can predict energy efficiency given some information about a building, and that is the major goal of this project. Can we predict the energy efficiency to a reasonable extent using various information available for buildings. So the problem statement is divided into three parts. The first part is identifying major factors that influence building energy efficiency. What could be is it dependent on building on a building's characteristics like its dimensions or the area, the year it was built in, its design, and secondly, what are the relationships between these various building parameters? How do they vary with energy efficiency? And thirdly, can we build models using these parameters to predict an energy efficiency of a building? The software and tools I'm using for this project include working on a Windows 10 operating system and using a statistical software for visualization and certain statistical tasks called RStudio. So and for programming I'm using Python and the associated modules and APIs like scikit-learn, pandas and numpy, which have I've already installed on my operating system. The data set for this project I'm using is from the building performance database. It's available at the given URL, and a snapshot of the database is shown here. It contains data for various parameters which can be associated with energy consumption in buildings, and it is available for multiple US cities. It's available for around 10 to 12 US cities, and I'm just considering Cambridge here as a case study. It has data for 2016 and 2017 available, so I'm just using data for that city. And the parameters are the same for other cities as well, so we could have used either of the cities and it would not have made a lot of difference. The parameters reported are building details like year it was built, the name of the building, the latitude and longitude, the type, whether it is a residential or a commercial building, the floor area, the equivalent greenhouse gas emissions corresponding to the energy consumption in the building, the energy usage intensity, which is the energy consumed per unit area, is a measure of how energy efficient a building is, and the energy star rating, which is a rating given to a building, and it's very commonly used as a metric to represent the energy efficiency of a building. This is a sample. This is a sample file for the Cambridge data I'm using. So as you can see, it's available in the Excel format, and it has several columns, as I mentioned. So for example, you have property name, property type, its address, the city, it's Cambridge, the state, the floor area, the year it was built in, the energy star value, and various other factors. So it also has a lot of blank values. As you can see, several of the columns are blank, so these blank values were removed before I started the data processing, and all of this data is available as Excel files. The blanks are removed, and this is another plot showing all the columns of the data set. So installation and configuration of the software I'm using. RStudio is downloaded from the website rstudio.com, and the procedure is self-explanatory. You just have to click on next for most of part of the installation, and it gets installed conveniently. I needed several packages which I installed using the install.packages command, the name being replaced by the package I wanted to install. For Python, I downloaded it from this website, python.org. I downloaded Python 3.7, and the remaining modules and APIs were installed using the pip install module name command, in using Cygwin as a Linux environment in Windows. So these were the installation details. Here is a sample data visualization for two parameters as a function of the energy star score. The first one is the building floor area. So we do not see a very clear relationship between building floor area and the energy star score. But the second one, which is the weather normalized source energy usage intensity, which is the use of energy per unit area normalized for the weather. So extreme weather will not change this parameter. So when we consider this parameter as a function of the energy star score, we see a decline as energy star score increases. So a higher energy star score means that the building is more energy efficient, and which would correspond to a lower energy consumption. So this relationship makes sense. So this was a demonstration of the data we are using in this project. So the variables of interest, as I had shown in the earlier slides, there were several variables available in the file, but the ones which we are most interested in are the energy star score, which is a measure of the energy efficiency of the building, the energy usage intensity, which is the energy consumed in the building per unit area, the equivalent greenhouse gas emissions corresponding to the energy consumed in the building, the year of construction of the building, and the floor area. So first off, I studied how these parameters correlate with each other. So here is a plot showing the correlation matrix. So there are 5 variables which I considered here, and each of the rows and columns of this matrix show the correlation between the two variables. For example, between 1, which is the floor area, you have a perfect correlation of 1 because it is the same variable. However, between 1 and 2, you have a perfect correlation of -1. So similarly, so most of the variables were highly correlated. They had perfect correlations. and several of them did not have any correlations. I have shown the variable here on the left corresponding to the numbers here. So for example, between floor area and greenhouse gas emissions, you had a perfect positive correlation. That means if the floor area was increasing, the equivalent greenhouse gas emissions were also increasing, which might make sense, because the more area you have, the more energy is required to meet the energy requirements of the building, which might give us higher greenhouse gas emissions. So that might make sense. Similarly, you have the source energy utilization intensity and the greenhouse gas emissions. They are also positively correlated. So the more energy is utilized, the more greenhouse gas emissions would be associated with the building. So these correlations, several of them made sense physically. Here is the corresponding code which I had written in R. I'm using the library code plot for getting these correlation plots. So moving on to studying the major factors that would influence building energy efficiency. So for this I'm using a machine learning algorithm called the extra trees classifier. This algorithm can be used to determine which parameters influence a given dependent variable. We can get an order as to which parameters influence the dependent variable the most. So here is the code for that. I wrote this in Python, and this is the result, which is explained here. So this is just a list showing the values corresponding to each parameter. The higher the value, the more important it is. So as you can see, most of the variables are important in predicting the intensity. However, the most important ones are the energy utilization intensity, which is how much energy is utilized per unit area. They overshadow the floor area and the year built variables. So, and also the equivalent greenhouse gas emissions, it is also an important variable. So from this we can conclude that site energy usage intensity, source energy usage intensity, and the normalized forms of these two are much more important than the dimensions of the building or the year it was built in, which probably makes sense, because year built would not represent how the building has developed. Since it was constructed, for example, there might be several modifications made to the building which might improve its energy efficiency even though it was constructed earlier, and maybe a later building which was constructed was not very energy efficient, so it could have a lower energy efficiency. So that might be a reason why this year built variable is not that highly rated. So next step is predicting the energy efficiency. So for this I am using a simple linear regression model with all the previously used variables. So I have written this model in Python, and these are the regression coefficients. My R square value was decent, but it was not very high, which I'll probably discuss in the next slide. However, there were some relationships which were quite confusing. For example, for some energy intensity variables, the coefficients were negative. However, for some it were positive. So this was something which I could not really explain in this analysis. However, I hope probably a more detailed analysis might be helpful in this. So the pros and cons. The pros were that linear regression did a reasonable job in predicting the energy efficiency. For example, the R square value was reasonably high, even though we were using a large number of variables. The extra trees classifier was a useful method. Initially I was trying the principal component analysis, but I think this method was a much better method to quantify the relative importance of various predictors for the regression equation. The cons were that some regression relationships were questionable, as I showed earlier, that some of them were negative and some were positive. And year built, this variable should be used with caution, since, as I mentioned earlier, buildings change and year built may not be an appropriate representation of energy efficiency.